The National Electrical Code, or NEC, does allow for polyvinyl chloride, or PVC conduit, to be installed on the surface of walls and in drop ceilings. However, it must meet certain requirements, including being supported and fastened securely and not being exposed to physical damage. Some local fire codes may have additional restrictions on the use of PVC in certain areas, such as new smoke detectors or fire extinguishers. However, there are no widespread fire codes that prohibit the use of PVC conduit in that manner. The claim that PVC spreads fire faster than electrical metallic tubing, or EMT, is incorrect. PVC is a fire-resistant material with a low flame spread rating. EMT, while more durable, can still conduct heat and contribute to the spread of fire. There could be a misinterpretation of regulations. The inspector may have misinterpreted the NEC or local fire codes or applied them incorrectly. The inspector may not be fully knowledgeable about the properties and applications of PVC and EMT. Some inspectors may have personal preferences for certain materials and methods which can influence their rulings. Firstly, contact the inspector's supervisor. Explain the situation and provide evidence to support your claims. Secondly, review the NEC and local fire codes. Verify that the installation meets the applicable regulations. Thirdly, consult with a licensed electrician. Get a professional opinion from a qualified electrician to confirm the legality of the installation. If necessary, file an appeal with the city or appropriate authority to challenge the inspector's ruling. When installing PVC conduit, the NEC provides guidelines that ensure safety and compliance. Article 352 covers PVC conduit, outlining approved uses, installation methods, and specific requirements. It's important to understand these requirements to avoid code violations and ensure a safe electrical system. One key aspect is proper support. The NEC specifies how frequently PVC conduit must be supported to prevent sagging and potential damage. The spacing between supports depends on the size of the conduit, with smaller conduits requiring more frequent support. Using appropriate support hardware, such as straps and clamps, is crucial. Another consideration is protection from physical damage. While PVC is durable, it's not indestructible. In areas where the conduit is exposed to potential impact or abrasion, additional protection may be required. This could involve using a thicker-walled conduit or installing a protective barrier. Expansion and contraction are also important factors to consider, especially in outdoor installations or areas with significant temperature variations. PVC expands and contracts with temperature changes, and if this movement is not accommodated, it can put stress on the conduit and connections. Expansion fittings are designed to absorb this movement and prevent damage. When running PVC conduit in concealed locations, such as within walls or above ceilings, it's important to follow specific guidelines for fire stopping. Fire stopping materials are used to seal any openings around the conduit to prevent the spread of fire and smoke. The NEC provides detailed requirements for fire stopping in Article 300.21. Bending PVC conduit requires special tools and techniques to avoid kinking or cracking the conduit. A conduit bender is used to create smooth, consistent bends. Heat can also be applied to make the PVC more pliable, but care must be taken not to overheat it, which can weaken the material. When connecting sections of PVC conduit, it's important to use appropriate fittings and adhesives. PVC cement is specifically designed to create a strong, watertight bond between the conduit and fittings. Proper preparation of the surfaces is essential to ensure a good bond. Before applying the cement, the surfaces should be cleaned and roughened to remove any dirt or debris. The NEC also addresses the use of PVC conduit in specific locations, such as wet or corrosive environments. In these areas, special precautions may be necessary to protect the conduit from damage. This could involve using a corrosion-resistant coating or selecting a conduit material that is specifically designed for these conditions. Grounding is another critical aspect of electrical safety. The NEC requires that all metal electrical enclosures and equipment be properly grounded to provide a path for fault current to flow back to the source. This helps to prevent electrical shock hazards. When using PVC conduit, which is non-conductive, a separate grounding conductor must be installed within the conduit to provide the necessary grounding path. The size of the grounding conductor is determined by the size of the circuit conductors. It's important to consult the NEC tables to ensure that the correct size grounding conductor is used. In addition to the NEC, local codes and regulations may also apply to PVC conduit installations. These local codes may be more stringent than the NEC and may include additional requirements. It's important to check with the local authorities to determine what codes and regulations apply in a specific area. When dealing with electrical inspections, it's important to be prepared and professional. Before the inspection, review the NEC and local codes to ensure that the installation meets all applicable requirements. Have all necessary documentation, such as permits and plans, readily available. During the inspection, be cooperative and answer any questions the inspector may have. If the inspector identifies any issues, address them promptly and professionally. If there is a disagreement with the inspector's interpretation of the codes, it's important to remain calm and respectful. Ask for clarification and provide any documentation that supports your position. If the disagreement cannot be resolved, follow the established procedures for appealing the inspector's decision. When choosing between PVC and EMT conduit, there are several factors to consider. PVC is generally less expensive and easier to install, while EMT is more durable and provides better protection against physical damage. PVC is also non-conductive, which can be an advantage in some applications. EMT, on the other hand, provides a built-in grounding path. The choice between PVC and EMT depends on the specific application and the requirements of the NEC and local codes. In some cases, a combination of both types of conduit may be the best solution. For example, PVC may be used for the majority of the run, with EMT used in areas where additional protection is needed. It's important to carefully evaluate the pros and cons of each type of conduit before making a decision. When working with electricity, safety should always be the top priority. Always energize the circuit before working on any electrical equipment. Use appropriate personal protective equipment, such as gloves and safety glasses. Follow all safety procedures and guidelines. If you are not comfortable working with electricity, hire a qualified electrician to do the work. Electrical work can be dangerous, and it's important to take all necessary precautions to protect yourself and others. Understanding the NEC and local codes is essential for ensuring a safe and compliant electrical installation. The NEC is a complex document, and it can be difficult to interpret. However, there are many resources available to help you understand the NEC. These resources include books, websites, and training courses. It's important to stay up to date on the latest changes to the NEC, as the code is updated every 3 years. By understanding the NEC and local codes, you can ensure that your electrical installations are safe and compliant. Inspectors play a crucial role in ensuring the safety of electrical installations. They are responsible for enforcing the NEC and local codes and for identifying any potential hazards. While some inspectors may lack the necessary training and experience, most are dedicated professionals who are committed to ensuring the safety of the public. It's important to work cooperatively with inspectors and to address any issues they identify promptly and professionally. By working together, electricians and inspectors can help to create a safer electrical environment. In summary, PVC conduit is a versatile and widely used material for electrical installations. However, it's important to understand the NEC and local codes to ensure that it is installed correctly and safely. By following the guidelines and taking the necessary precautions, you can ensure that your PVC conduit installations are safe, compliant, and reliable. The information presented is for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrician or electrical engineer before undertaking any electrical work. The NEC is a comprehensive set of standards, and it's important to refer to the specific articles and sections that apply to your particular installation. The NEC is constantly evolving, and it's important to stay up to date on the latest changes. By understanding the NEC and following its guidelines, you can ensure that your electrical installations are safe, compliant, and reliable. Remember to prioritize safety and to consult with qualified professionals when needed. With proper planning, installation, and maintenance, PVC conduit can provide a safe and reliable pathway for electrical wiring.